All right, so the question says that we're dealing with a block of metal. We've got a mass and we've got a volume, and we want to figure out the material using the density, right? So this, if you don't remember how to solve a problem like this, make sure to watch my video on mass and density. And that's part of the broader physics course, and I'll put the link in the corner here. But essentially, we want to use the equation density is equal to mass over volume, right? So we see that we have got a list of densities of materials here, and the units are grams per centimeter cubed. Grams per centimeter cubed, right? And we know that that's a unit of density because it's a mass over a volume, right? A cubic unit is always going to be volume. So a cubic centimeter is volume, so mass over volume. And so, of course, density, which we represent with the Greek letter rho, is equal to mass over volume. And so we want to calculate the density of this particular metal, and then we want to compare it to this table to try and figure out which metal we're dealing with. So it's going to be equal to the mass, which is 1.98 kilograms, over the volume, which is 440 centimeters cubed. All right, and of course, the problem here is that this is going to give us units in terms of kilograms per centimeter cubed, and we want to be dealing with grams per centimeter cubed. So I'm going to go ahead and convert this 1.98 kilograms into grams. And to do that, we just multiply it by 1,000, right? There are 1,000 grams in a kilogram. So I'm going to go ahead and do that right now. So we move the decimal point 3 places, 1, 2, 3. So it'd be 1980, 1,980, right? So 1,980 grams per centimeter cubed, or divided by 440 centimeters cubed. And the units would be in terms of grams per centimeter cubed, which is what we want. Okay, so what's 1980 divided by 440? I'm going to go ahead and round these values. I'm going to say this is 2,000 divided by, I'm going to say 500, just so that the math works out, right? And of course, 2,000 divided by 500, and we can always use this trick of crossing off zeros. So we cross off 2 zeros on both sides, and now it's 20 divided by 5, and that's going to be equal to 4, right? 20 divided by 5 is 4 because 4 times 5 is 20. So the correct answer here is going to be, or based on our rounding, is going to be 4 grams per centimeter cubed, right? Now, based on our table here, right, our table over here, we see that if we look at the 4 materials, what are the 4 materials that we're given? We're given aluminum, titanium, vanadium, and zinc, right? So essentially it has to be one of these 4, right? So obviously it can't be any of the rest of these. So we can just go ahead and kind of cross those off. And based on this table, it looks like 4 is about closest to 4.5, right? Could be maybe this. Maybe we want to take a look at that. It's probably not going to be vanadium or zinc, right? And so just to confirm in terms of our rounding, right, we rounded this bottom number up, so it was actually a little bit of a smaller number. So when we made it a higher number in the denominator, our overall density decreased. So it makes sense that our density should be a little bit higher. And so it makes sense that we're dealing with titanium, C, right? And so the correct answer here is going to be C, that the density of this material most closely matches the density of titanium. And so it's probably going to be titanium.